Okay, so today we actually start a new module. And this module only involves integration formulas. All right, so it provides for us more ways to integrate difficult functions. So I'm going to get started here with the notes. All right, so the purpose of this module is to recognize when to use integration by parts, to use the integration by parts formula to solve integration problems, and to use the integration by parts formula for definite integrals. So basically the goal of integration by parts is to compute an integral of the product of two, and I said or more, because that can be difficult, but the product of two functions. So if we have something like the integral of f of x times g of x dx, we want to be able to integrate that. So what are the basic things that you're going to need to know for this? You're going to need to know things like the integral of all the trig functions and the integral. So what's needed? Okay, so let me just add that little tidbit here. All right, so what's needed? I'll insert that in my notes. All right, so what is needed? Okay, so knowledge, or I should say, and I'm going to even say mastery, because you got to know it, of trigonometric functions, inverse trigonometric functions, exponentials. Those are the major ones. Those are the major ones that you will be using for this section. All right, so that means you need to know the integral of sine is negative cosine, the integral of cosine is sine. The integral of, we did the integral of tangent, it was the log of the absolute value of secant. Those kind of things you need to know, in those basic functions. Okay, then we're going to derive this formula. So now one of the things I noticed on the exam that I was grading is that some of you get trapped in the derivation of the formulas and then don't actually know how to utilize the formulas because you're still trapped in the derivation. So I'm going to be very quick on the derivation because I don't want you to focus on that. So the kinds of integrals we need to be able to integrate are things that look like x times e to the x. We can integrate x and we can integrate e to the x, but how do you integrate x times e to the x? We can integrate x squared. Oh, that was the other thing of polynomials. Knowledge of integrate polynomials, trigonometric functions, inverse trig functions, exponential. So you got to know how to do that. The power rule, we have to know that. Okay, so the integral of x squared sine x dx, that's another one. We got two functions. How do we integrate it? The integral of tangent inverse of x, well, there's only one function there, but the question is, how do we integrate that? Because it's an odd function, and it's not something that we've done. So here's the formula. So let's recall the formula from differentiation. Okay, so we want to recall the formula, the product rule for differentiation. Okay, so the product rule for differentiation says, if I want to take the derivative with respect to x of f of x times g of x, I'm going to get the derivative of the first times the second plus the derivative of the first I'm sorry, plus the first times the derivative of the second. Okay, so that's the product rule for differentiation. Okay, so now I want to apply this to a product of UV. So I want to now apply this to functions U of X and V of X. All right, so I want to apply that to those functions. So when I go to apply this product rule to these functions, I get that the derivative with respect to X of U of X times V of X is U prime of X, V of X, plus V prime of U of X, V prime of X. Okay, so now we already know that we just used the product rule. So now let's integrate this. All right, so when I go to integrate this, I get the integral of the derivative with respect to X of U of X times V of X dx is the integral of U prime of X V of X dx plus the integral of U of X V prime of X dx. All right, so now I want to solve for this term. Okay, so the first thing is when I do the integral of the derivative, I'm just going to get U of X times V of X. And then I'm going to subtract this and get the integral of U prime of X, V of X dx. And that is equal to what I have in my block, which is the integral of U of X, V prime of X dx. So we're going to actually call this the function U. So I get U times V. If I subtract off the integral of V of X, and I'm going to make this U prime of X dx, I get the integral of U of X V prime of X. And this should still be dx because I haven't switched it to U yet. And so here is what I end up with as my formula. So this thing over here, this purple thing, is the integral of U of X times V of X dx, which I can write as the integral of dV is U prime of X dx, and U is just U. So here, dV is just V prime of X dx, and du is just U prime of X dx. And so here is my formula for integration by parts. So this is the integration by parts formula. And all you need to do is make the substitution. So now, if we were actually in a classroom, I would have you walk into the classroom and say, what's the integration by parts formula? And in order to get in the room, you'd have to say, oh, the integral of U dV is equal to UV minus the integral of V du. You don't do it, you get to the back of the line and you get it right, and that's how you get in the classroom. Okay, so these are the problems. These 6 right here are the first problems that we are going to work on. Sometimes it depends on how long it takes to get through all the material. A lot of times it takes more than one lecture, and especially today being a short lecture, I expect that we're going to be going into tomorrow with this. Okay, problem number 1. Okay, this is the one we're going to work on first. Okay, good morning, Samuel.
Morning.
Okay. All right, so let's do this. Now, I like, this was my favorite part of calculus, was this module. I am hoping that this module, you guys find this module easier, and you can get a hold of this module, and then it'll help you with some of the other stuff that we've done. Okay, so again, this is a direct substitution. I can say to you this, before we do anything, this answer is not 1/2 x squared cosine x plus c. You cannot integrate the x and you cannot integrate the sine. Okay, that is not the way you do this. Okay, so this is a u substitution problem, but we need to identify u and v. Okay, so here's the problem. And what we need to do is we need to identify u and dv. All right, so for me, I always like to make u something that when you differentiate it, it gets easier. And I would say for 95% of the problems that we'll do, that's what's going to be. U will be something that's usually a polynomial, and it'll be something that gets easier when you differentiate it. Okay, so for this problem, we're going to let u is going to be x. Okay, so if u is x, then everything else has to be dv. Everything else, because I can only have 2 things in the integral. All right, so let me just pull my formula down here so you guys can see it again. I'll plop it right back in here. Where's my formula? Here it is. Where's my formula? Okay. Oh, that's why I'm in the wrong thing. Go to draw, go here. There it is. Okay, so we've identified u, and so dv is the sine of x dx. Okay. All righty. I need to find du. So du in this problem is just dx. And I need to find v, which is the integral of that. So that's minus the cosine of x. And I don't have to worry about the plus c because the constant falls out of the problem. All right, so now I know that this part right here is dv, and this part was u. So now notice in the problem, we have u and dv. We also have u and v, and we have v and du. But we have everything. Notice we have u, du, dv, and v. Okay, so therefore, I can take my my integral. So this is u and dv. This is going to equal u times v. So u is x and v is negative cosine x. So that's the uv part. So this is u times v. And then now I need minus the integral of v, which is negative cosine of x, du, which is dx. Okay, so all I've done is my general substitution. Okay, so again, I need u dv, then I find du, and then I integrate to find v. So I differentiate u, I integrate v. Differentiate u, integrate v, and then I plug it in. And so now this is negative x, the cosine of x, minus negative gives me a plus the integral of the cosine of x dx. What's the integral of the cosine of x? Somebody. Integral of cosine x.
Negative sign of x.
Okay, it's actually positive sign, but that was a good guess. I appreciate you. Thank you. And we're done now, so we can put plus c. Okay, so we get the integral of x sine x dx. All right, so there's our answer. All right. Uh-oh, that looks weird. I'm missing an x. Okay, now it looks right. Looking kind of weird for a minute. All right, so here's our next problem. Any questions about that so far? I know that's the first problem. It's kind of like, what? But here's the second problem. We'll start to catch on. So the second one is the integral of x e to the x. So here's number 2. All right. So once again, I need to identify u and dv. All right, so since I like the fact that making x a polynomial works for me, why don't I let u just be x. So u is just the x part. And then, I hope those are the same colors. Yes, they are. Okay. Then dv is the only thing that's left in the problem. So that is e to the x dx. So dv is all that's left. Okay. All right, so now I need du. Du is easy. It's just dx. And I need v, means I need to integrate e to the x. And when you integrate e to the x, you get?
E to the x.
E to the x, thank you. Okay, so therefore this integral is going to equal u, which is x, times v, which is e to the x, minus the integral of v, which is e to the x, du, which is dx. Again, if we need it, where is it? Dun, 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 dun. Okay, there's our formula. So here's u is x, dv is e to the x dx is equal to u times v. So this is u. And this is v minus the integral of v, this is v, du, and du is just dx. So now I have to do that integral. So I get the integral of x e to the x dx is equal to x e to the x minus, and when I integrate e to the x, I get e to the x again, and then I get plus c. So there is my formula. Uh-oh, what in the world am I doing? Okay. All right, let's do a definite integral. Hello. Okay, so in order to do this definite integral, I will take exactly what I got from my integration by parts and evaluate it. So notice I got the integral of x e to the x dx equals this. So now I'm going to use the fundamental theorem of calculus. So the most general antiderivative of x e to the x is what we just found, x. So let me make this a little function. I'll make this little f of x. All right, so it's big, and so its most general antiderivative, big F of x, is x e to the x minus e to the x. Okay. So we're just going to use the fundamental theorem of calculus. So we get the integral from 0 to log 4 of x e to the x dx. Well, you know what? I can write this as e to the x times x minus 1. That's easy. So this is e to the x times x minus 1, and it's evaluated between 0 and natural log of 4. So I'm going to put in natural log of 4. So I'm going to get e to the natural log of 4 times the natural log of 4 minus 1. And then I'm going to subtract off e to the 0, and then 0 minus 1. Okay. So I get e to the natural log of 4. Can anybody simplify that for me? E to the natural log of 4. What does that simplify? Okay. We got to remember e to the log are inverse functions. So that's
4.
just 4, yes. Times the natural log of 4 minus 1. And then e to the 0 is 1, so this is plus 1. And that's the answer. Okay. All right, so that's the answer to that problem. Okay. Next problem. Whoa. Okay, notice we have x squared, right, guys? Anybody having trouble with this? Okay, anybody having trouble with this? Okay, I don't see anything in the chat. Okay, so, all right, so here's the next problem. I guess this is problem number 4, maybe. Let's see, we did, yep, x sine x. I got an answer. We did x e to the x, and we got an answer. This one just gave us a number. All right, let me see if it'll actually give me the value. It might. 4 times natural log of 4 minus 1 plus 1. Yeah, there's the answer. Actually gave me the value. Okay, so that's what this one is. But this one, what's different about this one? This one was a definite integral. So for a definite integral, I'm going to get a number as an answer. And that's what we got. Okay, so now we're on to another one. We're going to do integration by parts again. All right, so here we go. What's u going to be in this problem?
X squared.
Good. And dv is everything that's left. So du is what now?
2x dx.
2x dx. A lot of folk forgot that dx on the test, and that messed them up on some problems. And v is equal to what? Integral of e dx is?
E to dx.
E to the x.
Okay, so do I have everything I need for this? I do. So now when I go to do this integral, I get u, which is x squared, times v, which is e to the x. So we start off with u times v. Then we do minus the integral of v times du. All right, so far looking pretty good. So I get this integral is equal to x squared e to the x. I'm gonna add a little space in here. Just a little space for me. And then I'm going to get minus 2 times the integral of x e to the x dx. And what do you notice? If I notice anything? We get another integration by parts problem. So when our u looked like x squared, the du came down, gave us 2x dx, and that created another integration by parts problem. Now, if I had not already done this problem, I'd have to do it. But luckily, we've already done this problem. We did it. So we get the integral of x squared e to the x dx is x squared e to the x minus 2. Now, I already did the integral of x e to the x. Let's see where it was. The integral of x e to the x, here it is. It's x e to the x minus e to the x. And since we're done, we can put plus a constant. So now we get that the integral of x squared e to the x dx is equal to x squared e to the x minus 2x e to the x plus 2 e to the x plus a constant. Okay. Any questions about that? Okay. My next one is, oh boy, x cubed e to the x. What do you think's going to happen when I do x cubed e to the x? Anybody have an idea? What's u?
X cubed.
And dv?
E to the x dx.
du?
3x dx.
3x squared dx. And again, v for us, that was easy. It's just e to the x. So now when I go to do this problem, I'm going to get this equals u times v, which is x cubed e to the x, minus the integral of v, which is e to the x du, which is 3x squared dx. Oh my gosh, this just goes on forever. At least it feels like it does. So now I get x cubed e to the x minus 3 times the integral of x squared e to the x dx. And yet again, I have another integration by parts problem. But luckily, I already calculated it. If I had not calculated, I'd have to do it. So we have yet another integration by parts problem. Okay. So put this here. this is equal to x cubed e to the x. But I gotta subtract off 3 times the one we just found, which was x squared e to the x minus 2x. Can't even remember it so long. X squared e to the x minus 2x e to the x plus 2 e to the x. Okay, I think that's right. And so now we have a rule for the third one, because this one just keeps going. All right, so this one, the final answer for this is going to be x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus a constant. All right, so now, is there a nicer way to do this? Yes. All right, there's an easier way to do this. It's called the chart formula for integration by parts. And it works when the integrand contains x to the n, and n is a positive integer. So like x squared, x cubed, here's an x cubed. These, it will work. Okay, so let me show you how it works. All right, so the way it works, we're going to do the integral of x squared cosine x. So we're going to do that one first. So I have the integral of x squared cosine x. And what you do is on the left-hand side, you start off with u. So this is u right here. So you start off with u. So maybe, yeah. So u always goes on this side. So you start off with u. So in this problem, u is x squared and dv is the cosine of x dx. So we start off with u and dv. Does everybody see that? So there's u and dv. Okay, so we start off like that. Then you see the formula here on this side, it says differentiate. So on this side, we're going to take derivatives. Derivative of x squared is 2x, derivative of 2x is 2. And then there actually is one more. I just forgot to put it down here. Let me see, undo. Undo. I think, yeah. So take the derivative one more time, that's 0. And then this is sine x. Okay. Any questions so far for the rule? I haven't done anything. So on the left-hand side, you place u. On the right-hand side, you place dv. Then you keep differentiating until you get to 0. And you keep integrating along with it. Now we're going to cross multiply. So I'm going to multiply the x squared by the box underneath here, which is negative sine x. I'm going to multiply 2x by this box, and I'm going to multiply 2 by that box. Okay, anybody, any questions? All right, and then the last part of the rule is the signs change from positive to negative. So this one is going to be positive, this one's going to be negative, and this one's going to be positive. Okay, so here we go. The integral of x squared cosine of x, where u is equal x squared and dv is equal to cosine of x, is going to be the first sign is positive, so that is x squared times negative sine x. That is wrong. The integral of cosine is sine, not negative. The integral of cosine is sine. The integral of sine is negative cosine. The integral of cosine is negative sine. I don't know how I got that wrong. Integral of cosine is sine. Integral of sine is negative cosine. Integral, now it's right. Okay, now it's right. Now it's right. It was wrong. It was wrong. Okay, it's better to find it than not find it. So I get x squared times the sine of x. The second term is subtracted. So that's 2x times negative cosine of x. The last term is added. So that's 2 times negative sine of x. I'm done, so I can add my plus c. And so if you missed it, I'll do it again. You start with u on this side, that's u, take the derivatives until you go to 0. You start with v on this side and you integrate until you reach the 0. So integral cosine sine, integral of sine, negative cosine, integral of negative cosine, sine, negative sine. Then you cross them. X squared goes to sine x. 2x multiplies by negative cosine x, and 2 multiplies by negative sine x. Then the first product you put, which is x squared sine x, has to be positive. Then the second term that you put, which is 2x times negative cosine x, has to be negative. And then the last term is going to be positive. And so now I can write my full answer, which is x squared, the integral of x squared cosine of x, that does not look like a C, dx is x squared, the sine of x, minus the negative makes plus 2x, the cosine of x, minus 2 times the sine of x, plus a constant. Okay. Any questions? Okay. We want to apply this to the integral of x cubed e to the 2x dx. So here u is x cubed and dv, which is e to the 2x dx. Speaking of which, on the exam, you had to integrate e to the 1/2 x dx. So you divide by the 1/2 and you get 2e to the 1/2 x plus the constant. So over here, I have e to the 2x, and every time I divide by 2, so my derivatives go x cubed, 3x squared, 6x, 6, and then I forgot to put the last one because I know I don't need it. Oh, yes, I do. I need the last one. How did I forget it? This is 0, 0. And then this is 1/16. Okay. All right. So it's an x cubed problem. X cubed, 3x squared, 6x, 6, and then 0. So I keep integrating e to the 2x, 1/2 e to the 2x, 1/4 e to the 2x, 1/8 e to the 2x, 1/16 e to the 2x. Then I cross them. X cubed goes here, 3x squared goes there, 6x goes here, and 6 goes there. Okay, this is it. Okay, this one's going to be positive. This product will be negative. This product will be positive, and this product will be negative. So I get the integral of x cubed e to the 2x dx. It's going to be x cubed times 1/2 e to the x squared. I'm sorry, e to the 2x. I'm saying the wrong thing. Then I'm going to get minus 3x squared times 1/4 e to the 2x. Then I'm going to get plus 6x times 1/8 e to the 2x. And then I'm going to get minus 6 times 1/16 e to the 2x plus a constant. And we will finish that tomorrow. Oh, I didn't do attendance. Okay, I missed it today. All right, guys, thank you.